Okay, someone asked about the absolute value problems. Um, this is just a standard absolute value problem where you have your absolute value on your left side and it's equal to a number, a positive number, and we'll talk about why that's important later. But this is where you would take the original equation, which is the absolute value of x minus 2 equals 6, and you're going to set up two possibilities. It's either exactly the same, which is x minus 2 is equal to 6, or it is x minus 2 is equal to negative 6. So the right side became negative. And then you would just solve for the two situations. First, we add 2 to both sides, and we get x equals 8. And the second one, we add 2 again, and we get x is equal to negative 4. I can't stress enough, it's really important that you test these solutions out into the original problem. So if I put in 8 into the original problem, which is up here, we get 8 minus 2, which is 6, and the absolute value of 6 is indeed 6. Or put in negative 4 minus 2 is negative 6, and that's the absolute value of negative 6 is 6. So both of them come out correct. Now, the other examples are something that you have to do first. First, we have 2 times the absolute value of x minus 3 is equal to 4. Before setting up our two separate equations, we have to divide by 2 by both sides. And the reason why is because we have to get rid of that 2 that's in front of the absolute value. Once you do divide by 2, you're going to get your absolute value by itself, like so. And now we can set up our two problems, which is x minus 3 is equal to 2, or x minus 3 is equal to negative 2. And we do the same thing. We add 3 to both sides. We get x equals 5 on this one. We add 3, and we get x equals 1. Remember to use a calculator. All of these operations I'm doing very fast, but you can get them right if you just use a calculator. If we plug this into the original problem, we can plug it into the original, or we could plug it into this one where we have set up our 2. Either way, it should come out right. So put in 5. 5 minus 3 is 2. Absolute value of 2 is 2. That's correct. Put in 1. 1 minus 3 is negative 2. The absolute value of negative 2 is 2. And that's right. For the next one, here we have to move that 4 first. You have to move the 4 first. That gives us the absolute value of x plus 4 is equal to 2. Now set up our two problems, and you would have the x plus 4 is equal to 2, or we can have x plus 4 is equal to negative 2. Once you subtract 4 from both sides, you're going to get the answer as x is negative 2, x is negative 2, or x is negative 6. And I did that very quickly, I know, but hopefully you're understanding what I'm doing. If we put that in to the original problem, negative 2 plus 4 is 2. The absolute value of 2 is 2. 2 plus 4 is 6. If I put in negative 6, negative 6 plus 4 is negative 2. Absolute value of negative 2 is indeed 2. 2 plus 4 is 6. Now, the reason why I brought up this last one is because everything looks fine until we move that 6. Now, what happened? Well, why is something wrong? Well, because they have the absolute value of x plus 4 is equal to a negative 2. And it's important to think about these things as you go on, because here we have a problem. Anything that I put in for x, once it comes out of that absolute value, is going to be a positive number. There's no way it could ever be negative 2. So if we were to solve this problem like we normally do and set it up as two problems, I'll just do the first one. If we have x plus 4 is equal to a negative 2, right? Everything comes out, everything stays the same. You would think, oh, x is negative 6. But put in negative 6. Negative 6 plus 4 is negative 2, but that's the absolute value of negative 2, which is indeed 2, not negative 2. So you cannot have an absolute value of x plus 4 is equal to a negative number. This would be no solutions. And that comes up. So you have to be prepared to recognize that. I hope this helps, and I will post it on Google Classroom.